and we're going to discuss a problem about the approximation to a normal distribution. Given 1,500 criminology students with an average GPA of 2.8, their standard deviation is 0.2, and we want to find out how many students would have a GPA between 2.4 and 3.2. Now, since we have 1,500 people in the sample, and that is greater than 30, we can invoke the central limit theorem to say that this data may be assumed to be approximately normally distributed in the population. That allows us to translate whatever we're trying to find to the standard normal metric, the z-score, and use the associated probabilities with that. So here we have the general formula for a z-score. We were told in the problem description that the mean is 2.8 and the standard deviation is 0.2. Our objective is to determine the number of students between 2.4 and 3.2 on their GPA. And so we first need to know what proportion or what probability we would have a student in that range. And then we'll multiply that by our sample of 1,500 later. So the next step here, I want to translate that probability between GPAs of 2.4 and 3.2 to z-scores. So the first one, corresponding to GPA 2.4, would be determined by taking the difference of that with 2.8, the average, and divide by the standard deviation. That would give us negative 0.4 over 0.2 for negative 2. So our first z-score in this translation is negative 2. The second will correspond to the GPA value 3.2. And if we use our same formula for z, we can compute the corresponding z-score for 3.2. Take our difference, that coincidentally is 0.4 again, now positive, since 3.2 is higher than the mean, and divide our standard deviation for 2 yet again. So this is a nice whole numbered z-score reference for which we could use the empirical rule. Let's first look at our z-score table, because this would be useful later as you're working with z-scores to find the probabilities associated with z equal negative 2 and positive 2. So notice in this table to the right, we have our z starting down the column. We have a negative 2.0 here, so we would look in this row for the z equal negative 2 reference. And along the top, we see the second decimal place here. And since we have a whole number 2, we assume that is 0.00. So we look down this column and find where it meets the row that we identified from the whole number part and the 10th digit, 2.0. So that gives us this reference to probability 0.0228. And I always recommend drawing out the normal curve when learning these z-score and probability references. So what we just found was to the left of z equal negative 2, the area under the curve or probability is 0.0228. Then we would look up positive 2 on the right-hand side of our table, just like we did in the manner before. Isolate our 0.00 column, and we would come to this probability, 0.9772. What does that tell us? At z equal positive 2, the total probability to the left, in other words, all of this area, inclusive of that we already shaded in the blue, is 0.9772, or probability 0.9772. Now, to get the probability only within those two, we need to take the difference of those values we just found. So that would give us the area in the middle if we subtract those two terms. And you can take your calculator and subtract those two numbers, 0.9772 minus 0.0228 for 0.9544, roughly 95%, as the empirical rules suggest, between two standard deviations above and below the mean. So we have found this area to have probability 0.9544. And finally, we would want to take that and see what 0.9544 of 1,500 students is. Recall our total sample of students was 1,500. So at the final determination, we would say, okay, of these 1,500 students, we found that this proportion of them would have a GPA in that range. What number of students does that correspond to? By carrying out that multiplication, we would see there are roughly 1,431 students. We get a 0.6 here, so you would need to decide how many you want to say. We could say 1,432 if we rounded by conventional rules, but since this is, if you want to say strictly between, you could also argue to round down and say approximately 1,431 students score between 2.4 and 3.2 if you want to take a more hardline interpretation or conservative approach to how many you report. So there we have using the normal distribution to address a question about how many students would fall within a particular range, given that that GPA measure has the characteristics of a normally distributed variable.